Okay, this is the 2023 Examcraft Pre. So the first question there was the intersecting plane or interpenetration question there. But look, before I start there, and I'll just kind of go through it there slowly. I think from where the square prism goes through the pentagonal prism, how many points of intersection is there? So there's like 1 where it goes in here, 2 where it crosses the horizontal edge, 3 where that vertical line comes down there, 4 is at the top, and I'm counting here, so there's 2 down there, there's 1 underneath, and 1 down there, crosses over 2, they were the ones I was counting a second ago, and 3 and 4 brings you to the back here, and then there's 5 where it crosses over the top again, and 6 where that goes down here, and 7 where it crosses over there, and 8 where it goes back down underneath again. So there's, I think, 8 points on this, and just there, you know, there's a nice bit of work on this for a short question. So what I'm going to do there is going to just start off with that first point here where the vertical line is coming up. So that's horizontal over from here, so that there is point 1. Going in there. Now I was saying point 2 then is where it cuts through the edge, and that's a matter of where that horizontal line here cuts through the side of the square base prism. So I'm bringing that up from the plane. So I projected that up, and I want to bring the height of that across. So that is 2. And I'm going to join these now as I go there, just to kind of make it easier for you to follow, hopefully. So that is 2. So that means that this line coming over here then is heavy. 1 and 2. Then it goes back out, upwards and outwards again to where this in view here, where that line is coming down here. That's going to be our height for that. Okay, so they actually had given you the final point of that. So that is 3. So 1 to 2 to 3. Now the next point we want is the back. Now that is here. Or in other words, if I follow that over and up, it's this point here. So that's going to be point 4. So because if I was just to show you there, if I brought that over to the in view and up, that is that back edge there. I can put a B for back edge on that if I wanted. But anyway, so when I brought that across and up from the top view, so that is my point 4. Now the problem is, because this is going around the back here, now it's dotted. So 3 to 4 is dotted. And from the top view here, then you can see that whoa, 1 second, oh no, it goes over the top here first. Whoa, abort. It goes over the top edge here first, which when I bring that up, and I'll just bring the height of the top of that prism across. Okay, so it doesn't go straight to 4. Okay, so this is 0.4 here. It is dotted. So 2 to 3 to 4. And then down a bit lower there to, so that is going to be 0.4. Back down then a little bit to 0.5. Back up again to that top height here, which is up from there. That's going to be 0.6. And then goes down to where this edge drops into the roof, which would be the dotted height here, the height of this dotted line there. So that's this dotted line. So that is here. So I call that 0.7. So it goes from 6 down to 7. And we're now down here, so it comes back down here to this front corner then. So that's coming in heavy as far as there. So that's corner 8. And from 8 then it goes back down to, here was an awkward corner here now because it's this dotted line underneath and it's kind of hidden around the corner here. But it's this point here where that dotted line for the surface on the ground, where the ground edge there meets. So I'm bringing that up to the ground and it's going to there. So that would be 9. So there was 9 points involved in that. Now I want to heavy in there then. So that edge is dotted there and coming back out dotted again here. So as I said, there's a nice bit of drawing now and a nice bit of understanding in that question 1. So I said complete the elevation of the red window section. Okay, so I didn't do that now. And it's a complete the interpenetration. So I've done the interpenetration first. So the window, which is red, it's kind of hard to see in the camera, but there's a window inside here in the middle of this. And so it's straight up from there, straight up from here. So the question is, how do you find the heights for this? Now there's 2 easy enough ways to find those heights. I'll talk about it, I guess. Now, one way would be to bring the window, the red window is shown here in the dotted rectangle here. So I could just bring it out to the in view, up and back over again to the elevation. So I will look at doing it that way. So bring out to the in view, up, and back across. So that would be one way of doing it. So there's the bottom, here's the height of the top. And that there is the window. Now the other way I could have done it is because of the angled edge on the pentagon here, I could have just taken them to the left like this and brought them up from there, but I know they're very, very close to each other. But if I brought them up to the outside edge here and there, like technically that would be correct, but it's very hard to get it accurate. Like I'm getting a height of there and a height of here, but I think it's easier to take them around the long way to the end view and back across. So that there is the first question, but as I say, for a short question there was a lot of drawing in that. Now moving on to A2 here, it says determine the true length of the line of intersection between surfaces A and B. Now surfaces A and B is on the inside, okay? So I'm going to give these numbers, and maybe I should even colour it in. So I'll grab a green colouring pencil here and I'll just slightly colour that in there so maybe you can see it a bit better. But that there, and it's here in elevation, that dotted line there, because it's the inside surfaces. So if I number the top of that 1 and 2, so 1 and 2, that green line there is the line of intersection. So basically what you need to do is look at 90 degrees to that. So because this is higher level, please, I'm not going to go through I'm going to presume that you know what an auxiliary elevation is. So just line that up there. I'm going to go at 90 degrees to that. So we're projecting up here. So I'm going to put an XY line there just above that a little bit. So I'll just call that XY1, because that's my first XY line here. Okay, so I'm going to take my measurements. Now this is a small thing, but an important thing. I'm going to take my measurements from up a few mil here. I'll call that a reference line or a datum line. So that point 2 is now 0 distance. Just makes life easier. So point 2 is 0 distance, and the height of point 1 from that reference is up that much higher. So be careful there now that I'm taking that, you know, not off the XY line. Now that is the true length of the line of intersection. And if I look along that, which I'm going to, I'll just do it, I suppose. So if I look along the line of intersection, I am going to see a point view of it. So that's my angle for projecting there. I'll just set this up. So that's the angle I'm looking at. So I'm going to put an XY line just a tiny bit above that. Well, it's going to be XY3, that's the third XY line I've used. Sorry, XY, XY1, sorry, XY2. So here is the rule. I'm projecting from this view, so that's from the last XY line back. Okay, so my distance is back to both 1 and 2 is that far. So that there now is the point view of both 1 and 2. But to finish this now, I need another 2 points on both on triangle A and triangle B. So I'm going to call this triangle, I'm going to call this point 3, and I could pick this point over here at the end if I wanted, or I could pick a closer one. I'm going to pick a closer one, I think. I'm going to just pick a random point 4 here, or you could use the corner over there, it doesn't matter. So that point 4, and I'll just bring it up there and I'll just reference it up here as well. That's the point 4 that I'm working with. So when I project them up at the same angle as I did earlier on there to get the true length. So 4 is up from there, 3 is up from here. I should have actually put 3 and 4 in line with each other. It would have made more sense. It would make life a little bit easier. That was kind of stupid now if I may say so myself. Okay, so anyway, 4 is here and 3 is there, and when I project them out again then as the angle for the point view, now you could do all these in the one go, and that would be fine. So I'm projecting them out. So keep following the rule. Wherever you're projecting from, it's the last XY line back. That is always the rule for auxiliaries. So 3 is just back a short distance here. So that is point 3, and 4 is back the biggest distance. I've gone on to the writing there, but that's not a problem. So there's my dihedral angle now. It goes 1, 2 to 3 in this direction, and just double check that. So my distance to 1 and 2 is that far. My distance to 3 was that far, and my distance to 4 distance to 4, I knew that looked a bit small, right? My distance to 4 is that far. And that there, that angle is the dihedral angle. Okay, so determine the true length of the line of intersection. So I'm going to put a TL on that. And that was the line of intersection. So I might just put a bit of a green color on that so you can follow it. And this would have a green dot in because that's a point view of it there. So that was the point view of the line of intersection and 2 points with it. Now, finally there then, the last part of this was get the true shape of A. Now, there's a few ways that you could have done this. The easiest way, I think, is because the top of that 1 tree is horizontal, because the top of that whole surface is horizontal. I'm going to just hinge it up like a cat flap on a door, or like the tailgate of a silage trailer or something like that there. I'm not going to move the top. I'm going to bring it in this direction and take it away from the rest of the question. So if I swing that whole surface up there and bring it across, I might colour this in red there just to help you see it. So I've now swung, I didn't move. Okay, so that's it. Now, when you do that, I'm after swinging the bottom of it up to be horizontal. Now if I bring that down to plane, when I swung them, swinging that up looks like this, swinging that up looks like that, and these are my corners here now. This is 0.2 on the ground, and that's the other corner point. So I'm going to colour this in now in red to just highlight it. So that's our true shape here then. So we never move the top surface on the right at all. So for me that, no, is that right? That is right, yeah. So for me that is the quickest way to do it. And I might just colour that in with a highlighter or colouring pencil or something like that. I would prefer to have a better colour now, but so I just colour that in green to help you see where that true shape is. So I never moved the top right hand end, but I hinged up the rest of the surface until it was horizontal here in the elevation and brought it down. So I just stick an arrow there to say I hinged that up, brought it down, and that's the true shape. True shape. And that there is 2 of them done. So onwards and upwards, question 3. So it says V1 and V2 are the vertices of a semiparabola. Okay, so basically what they're saying there, if I talk about the one on the left here for a second, is that's the vertex of a semiparabola. So it is, if you had the full parabola, that's the vertex, but it's only a half a parabola. So sometimes it's not a bad thing to sketch these things out. So there are your sloping lines. These are your parallel to the sidelines. And there would be our semiparabola, like that. Okay, so there's the vertex, like that. So if you sketch that out there, it would help you to see it and to understand it. Now, thereafter starting this off for you, like, so, what they've already done here is they've done one of the distances. So I know that might be a bit confusing, but really, like, all you have to do there is measure that with your compass and step that down, and almost definitely it's going to work out to be the perfect equal distances, which it is. Okay, so they have like the hard work started off here. So those are my parallel lines, and it's the same then with the lines sloping up to the vertex. You'll be setting your compass, so they have the work done for you there because they've already done one. So all you have to do is just take that distance there. That's going to work out exactly even distances down here as well, as you can see. But these are the ones that slope up to the vertex. So okay, so there, here, and there, and starting off here. So that there is our parabola. Like that, or semi-parabola, and all you need to do there then to finish it, you don't need to do the reconstruction when it's symmetrical. So I just transfer these across now. You'll forgive me for drawing it a bit heavier than I would like to. And I could either use my compass because it's symmetrical. So how far from the so how far from left, same distance to the right. And that here is the first part of it on two semi-parabolas. But yeah, it would be easy enough now to kind of get confused on that as well, being a semi-parabola and that. Now, the second part here then, it said you were told there that AB is the major circle on the major axis, and F and F1 are the focal points. So you've got the focal points. So basically what's being asked here is, if you've got the major axis and the focal points, can you find the minor axis? Now look, there's two constructions for this. One is just come down from the focal point and across. That is the end of the minor axis. So down and across. That is one way of doing it, and or the other way that a lot of you might have done as well is take half the major, swing it from the focal point, giving you the end of the minor as well. So a lot of people do that. To be honest, they're both junior set constructions. So I'll just finish my half a minor circle. Okay, so there's minor circle, and then you're just doing a normal junior cert, bog standard concentric circles, ellipse here, or you could obviously do the trammel as well. So just throw on a few spokes there. And then parallel to the minor from all of these. And where each spoke cuts through the small circle, then parallel to the major. So first point, second, third, fourth. Just circle them in there to make it easier to see them. And now, if you don't like drawing freehand curves, I would recommend that you lightly join them up freehand. No, sorry, don't do this if you're good at curves, but you can join them up freehand, and then you need to be staying outside the center of them a little bit. Okay, so there is find the length and the minor axis and complete the semi-ellipse. So that is 3 done. So the fourth one here, you'll forgive me for going slow with these, but you know, it's kind of aimed towards people that are struggling with it. If you know how to do these, you won't be watching the video anyway. You're wasting your time watching this video. Just go and do it. But when you're doing these, what you need to do is you need to create a plane with a line parallel and a line horizontal. So it doesn't matter where we start, and I'm going to call this point X. So I'm after creating a triangular plane here now, CDX, but the DX is parallel to AB. And then I want to bring X down to plan. Do the same parallel that you already did then in plan. So parallel to AB from D. Parallel to AB. So parallel to AB from D. So this is point X now, because X has to be straight down from here. But this is the key thing now. It is the horizontal XC is the angle we want to look at. And if we look at that angle, so I'll just mark parallel again here to help you understand what I did. So parallel to AB from D and horizontal, bring X down, do the same parallel. So from D parallel to AB in plan, parallel to the plan of it now. So in the elevation you go parallel to AB in elevation, in the plan you go parallel to AB in plan, and it is X to C. There is the angle. Now if we look at that angle and everything else is done right, we should get the skew lines appearing as parallel. So I'm going to keep the XY line nice and close here now. So I'm going to call that XY 1. So I'm going to project all of those up. A and B. We've already brought C. And there's D. So remember the rule for auxiliary views. Whatever view you're projecting from the last XY line back, that is your distance. So I better do this accurately now. So I'll just bring these down for taking distances. So A is that height. Now, don't be trying to index these too small. I see people doing this on exam papers there, on pre's and stuff. So that's A, that is B. That's our first skew line. I'll draw it, I guess. And then C, and D. Now, if everything is done properly, those skew lines now should be parallel to each other. Now again, that looks pretty decent, but the smart thing to do here is don't just randomly join them and presume that it's perfect. Just line it up there, slide it over, and you could do a little bit of creative line drawing if you needed to. Okay, so that is C, that is D. Now, here is the key moment. Are you asked for the shortest distance, which would involve looking at 90 degrees to these? Are you asked for the shortest horizontal distance, which means you look along the ground? So that is very important to check that. So in this case, we were asked for the shortest horizontal distance. So because this XY line represents the ground, so you want to look along that ground in the auxiliary. So that's awful important, very important, vital, imperative, lots of big words like that, to check which you're asked for, because it's an easy one to mix up. So if it's the shortest horizontal distance, you have to look along the ground, because that's horizontal. So there's our lines. So I just put an XY line a tiny bit above this again, just to keep it pretty condensed. So this is XY2, or second auxiliary, and I'm projecting from here the last XY line back. That is where my distances are coming from. So distance for A, so distance for B, distance for C is the closest. And distance for D. So D, B, C, and A. Now, okay, so this here is the shortest horizontal distance right there, but we've got to get this information back to the plan and elevation. You can't just leave it sit there. So I might stick it in a different color there just to kind of help you follow it. So now we're just bringing them back at whatever angles you took those views out at. You're just bringing them back using the same angles. So just put dotted line. That there is our shortest horizontal distance. Now, because I'm going to show you a little trick here now, instead of projecting back and projecting back again, because all our distances for here, like we took the height of B above the ground, and that's where we got B from. So I can do that backwards now and take the height for that shortest horizontal distance, and I can just mark it back here. And this is more accurate by far than projecting. Now, they're both correct, but this is just more accurate. So that's the height of the shortest horizontal distance. And when I bring that down now, it's here on CD. And it's here on BA. So that there. Now if you wanted to double check, these will all line up, because if I brought it down parallel from the BA line there, you'll see that that there is just working out exactly the same point. So that here is our shortest horizontal distance here. So that's that done. Now they said on the drawing, indicate the angle of inclination of this line to the vertical plane. Now, really what they're asking you to do there, if I had a piece of paper there now, it would be great. Okay, so if I could just set this up. Here is the vertical plane standing up like that, and here is our line going at this angle, floating in the air. But what they're asking for like is, what's the angle of the line to the plane? So basically you just have to extend it in, and that is the angle. So if I just extend that angle in here, and that's what they're looking for there. What is this angle? So it's just important to kind of highlight it, or you could write in the degrees there by using a symbol like theta or something like that there, or using your arc with arrows. But that there is the angle of that line to the vertical plane. So yeah, because that's a horizontal line and that's a vertical plane. So if I just use the cap of the biro, so your line was like this, floating horizontal up in the air, so you just shoot it in there to hit it, and you're done there, because you don't really, you can't really show that in the elevation. So that is it. There was a nice bit of work there now, particularly on the first one there, and you know, parts of like the third one was probably relatively okay. So best of luck with that. Slán.